All right, so for this last problem for this section, we want to use the intermediate value theorem to show there's at least one real solution to this polynomial equation, x cubed plus 5 equals x squared minus x. And the first thing we want to do here is actually redefine this as a polynomial function and look at zeros of the function rather than thinking about this as an algebraic equation. So if we move all terms to one side, we have f of x is equal to positive x cubed minus x squared plus x plus 5. And now we want to look at finding the zeros of this polynomial. But before we go ahead and do that, we need to understand that the goal of this problem is to actually not find the zeros. Rather, we want to go through and demonstrate that there is at least one zero. We know from algebra there could be up to 3 zeros for this function, but the idea again is to show the existence of at least one. So to do that, we first need to take a note that this f of x function is continuous for all real numbers since it is a polynomial. Again, if we don't have continuity, we have no business trying to apply the intermediate value theorem. So the next thing to do is to guess some function values to test in f of x. And if we take a look at finding f of negative 2, we have negative 2 cubed minus negative 2 squared plus a negative 2 plus a 5. A quick calculation shows us that's equal to negative 9. And we need to calculate another function value. One that's nearby and pretty easy is negative 1. So that's going to be negative 1 cubed minus a negative 1 squared plus a negative 1 plus a 5. That calculates out to be a positive 2. So therefore, because our function switches from negative to positive, it has to pass through 0. So there must be at least one value in the interval from negative 2 to negative 1 such that f, and again our textbook likes using the value of c, is equal to 0. And again, this problem is not concerned with finding it, rather it's concerned with just showing the existence of such a number. So since the polynomial has a 0, we know that the algebraic equation must have at least one solution. And you'll see the graph of this function below the video link.